Okay, so now that we've got our application published to Heroku, but is our work finished? Well, not quite. And what we'll do is we'll take a look at securityheaders.com and see how we're getting on. Well, let's take a look at our competition first of all. So facebook.com is our direct competitor for our social networking site. And let's see how they're doing. Okay, they get an A, good for them. And how about Twitter? Not really a direct competitor, but we'll check it anyway. And, well, good, they get an A as well. And what about a small company like apple.com? Well, they get a C. Not particularly fair on Apple because that's just their front-facing website. I'm sure their stores have more security. But if we take a look at our app and just get the URL and paste it in to securityheaders.com and click scan, we get an F. It's like being back at school, and that's not so good. And if we take a look at what's going on here, we're missing a bunch of security-related headers that we're sending back with our response. And this is what's causing us the F grade here. And what does it tell us? Ouch. You should work on your security posture immediately. Good suggestion. And if we take a look at what's missing and why it's important that we add this, then we've got HTTP strict transport security, which strengthens our implementation of TLS by getting the user agent to enforce HTTPS. Now, if we go and take a look at our app, we are using SSL. Heroku provides us with a valid certificate. So it's not that we're not using HTTPS, it's just that we're not enforcing HTTPS. The next one is content security policy. And this is an effective measure to protect our site from cross-site scripting attacks. We can whitelist sources of approved content, and we can prevent the browser from loading malicious assets. Now, this is the big weakness in JWTs, our tokens we're using to authenticate, and also storing them in local storage. This is a big weakness. And if an attacker can inject malicious JavaScript into our application, then they can get the token from local storage remotely. So we can protect ourselves against that attack by using a content security policy. Also, X-frame options, and this tells the browser whether we want to allow our site to be framed in an iframe and loaded on someone else's site. Now, if that is allowed to happen, then someone can hijack our site by using our site in an iframe and adding malicious stuff around it, and it's known as clickjacking. So we can also protect against that. We've also got X content type options, and this stops a browser from trying to mime sniff the content type and forces it to stick with the declared content type. So we'll add this just because we can. And we've also got a couple of other policies here, a referrer policy, a new header that allows a site to control how much information the browser includes, and a permissions policy, a new header that allows a site to control which features and APIs can be used in the browser. So what we want to do is enable as many of these options as we can, and what we want to do is get an A grade in our security report here. So let's head back to VS Code and work on our security posture. And what we're going to do is we're going to add a helper package for this. And what we're going to do is open up the NuGet gallery. And what we want to look for here is nwebsec.aspnetcore. And we want the middleware. So nwebsec ASP.NET Core middleware. And this is going to allow us to add security headers to our responses. Now, the dependencies for this are version 3.1 of .NET. So it doesn't look like they've updated it specifically for .NET 5 yet, but I have tested it and it does work with .NET 5. So we're going to install this into our API project and click on install. And let's just close the terminal after it's finished doing its thing. And then what we can do is go to our startup class. And what we're going to do is just add the middleware that we need to add these different headers. So what we'll do is we'll add this fairly high up just after our middleware here for our exception handling. And what we'll do is we'll say app.use X content type options. And that was one of them that we looked at. What we'll do is also use an app and say use referrer policy. And we'll give this some options, and we're going to set this to say opt.noReferrer. So our browser will not send any referrer information. What we'll also use is say app.use XSS protection, and we'll give this some configuration. And we'll say opt.enabled with block mode to give us some cross-site scripting protection. And we'll also say app.use XFO, and this is to prevent our application from being used in an iframe somewhere else. And we'll say opt goes to opt.deny. And we'll add one final one, and this is the big one, and say opt use CSP. And there's two options for this. We can use CSP, Content Security Policy, but we're going to start by putting this in reports only, which will allow our application to work, but we'll get the information about what will not work in our console if we use Content Security Policy without the reports only option. So what we'll do is we'll give this some configuration as well. And we'll say opt goes to opt, and then we're going to chain on various policies. And we're going to say block all mixed content. So we won't be able to have HTTP and HTTPS content on our site. It's all going to need to be HTTPS. We'll also say style sources. Where can our CSS come from? And a lot of these for now, we're just going to specify self. So we're going to say self, and self means the domain where the content is coming from. We're going to say that we're okay with anything that's generated from our domain. And that's the published JavaScript files that we have, as well as the static content. We'll do the same for font sources, and we'll say s goes to s.self. We'll do the same for form actions, and we'll say it's okay for form actions to go to the same domain. So again, using self. We'll also say frame ancestors, and again, we'll specify s.self. We'll add one for image sources, and again, say s goes to s.self in this case as well. And then we'll specify script sources, and again, s goes to s.self, so we're okay with any JavaScript from our own domain. Now, this is reports only. So what we'll do is we'll be able to take a look at how this has affected our application, and what we'll do, we'll just open up the console once again, and let's just restart our API. And we're back in development mode now, by the way. We're not going to publish and then see how we're going. We're going to use our PostgreSQL local development server whilst we're changing our application, and then once we're happy, then we'll republish to Heroku. So first of all, we're only concerned with development mode. So let's take a look. So we'll say .NET Watch run and press return. And once our application has started, let's go across to our browser. And we want to go back to localhost 3000. Nope, not localhost 3000. We're not starting our client app. We're publishing this via our API. So localhost 5000. And we can go to our activities, everything still works. But what we'll find, if we go to our console and take a look and see all of the different errors that we have, and this is coming from our content security policy because it's in report only. Now we need to take a look at all of these different things and specifically allow them because we trust the source that they're coming from. And we'll take a look at these reports in the next lesson and resolve them.